Hi everyone. Today we are going to discuss how to find eigen vectors. Okay, another important thing. So let's study today eigen vectors. Okay. So what is an eigenvector? I've told you in that class about in the definition class ax is equal to lambda x is known as polynomial equation. Actually polynomial equation is this one, characteristic equation, actually this one, whatever. The value of x is known as eigenvector, where x represents a column matrix, or it can be written as x1 x2 x3. Okay, so this is our basic. So how can we find this x1 x2 x3? This is our objective of this video. Okay, so before proceeding, I would like to add something about that eigenvalue. In the previous video, I had taught you how you can find eigenvalues in three-dimensional case, but what in case of two-dimensional? Suppose lambda square minus trace. If it is plus, here it is minus trace. Lambda plus determinant. Okay, this is going to be the formula. For 3D, it is trace plus lambda sum of possible determinants minus lambda is equal to 0, and in this case it's going to be this lambda square, as I have written, minus lambda trace. That all possible determinant is not required here, because here one determinant is only possible, that is this one. Okay, so now we are going to solve a problem in 2D. How we can find the eigenvector, and for eigenvector eigenvalues are essential. Okay, let's solve. A is equal to minus 5 2 2 minus 2. Okay, and the characteristic equation is given by E minus lambda I, but we are going to find the value of lambda in that shortcut method, that is lambda square minus lambda trace plus determinant is equal to 0. Okay, so what is the trace here? Minus 7, right? So trace is equal to minus 7. And what is the determinant? Minus 7 minus 4, right? Oh. I'm extremely sorry why I'm telling this. I have actually yeah, this is not minus 7. 1 minute. For trace we need the sum. Sorry. For trace we need the sum. We have found out the trace, and for the determinant we are just going to multiply it. So minus 5 into minus 2 is 10, minus 4 is equal to 6. So in the next page we can write lambda square minus lambda, the trace is 7 minus 7, so minus 7 plus lambda, which is 6, is equal to 0. So what is our characteristic equation? Lambda square minus minus plus lambda 7 plus 6, okay, is equal to 0. Now let's solve it, which is very easy. Lambda square plus 7 lambda plus 6 is equal to 0. Middle term, 6 lambda plus 6 is equal to 0. Lambda plus 6 plus, okay, so what we are getting is that okay, lambda plus 1 and lambda plus 6 is equal to 0, right? So now what we are getting, lambda is equal to minus 1 and lambda is equal to minus 6. These are the two values of this characteristic equation, this one. Okay, good. So this is how we find the eigenvalues of a matrix in 2D case. In jam 2 marks are there and 1 mark question, so this type of problem might be asked if the question comes easy, depends on the institute. So 2D case is important than 3D case for objective kind of exams or any other competitive exams, not only IIT jam. Okay, so yes, so we can write ax is equal to lambda x. We can also write a minus lambda I x is equal to 0. Yes or no? Right. We can easily write this from, okay, there would be a multiplication x, just taking this in left side. So what's the value of a? I is the identity matrix, here 2-dimensional, and lambda value we have, first we have to check with minus 1, next step we are going to check with minus 6. So okay, what is the value of a? This one, no? Okay, a minus lambda I x is equal to 0. a होगा -5 2 2, yeah, minus lambda is, in first case I am taking -1 and I is the identity matrix 1 1 0 0 here. So it is obviously, okay, I'm doing here, okay, minus minus is plus, so just we people need to add actually, right? This thing will be addition. So minus, okay, -5 plus 1, -5 plus 1 and -2 plus 1, -2 plus 1, rest are 2 plus 0 and 2 plus 0, okay, and sorry, yeah, and we have x, which is x1 and x2. For a 2-dimensional case we are going to have 2 eigenvectors. For a 3-dimensional case we are going to have 3 eigenvectors. Okay, yeah, this one, this is x1 x2 and this equalizes to 0. There is nothing but this representation in matrix form. Okay, let's go to the next page. So minus 5 plus 1 is minus 4, and here it is minus 1. So we are getting minus 4, 2, minus 1, 2, right? Yes, yeah. And also x1 and x2, which equals to 0. Now just a basic matrix multiplication, hope you remember. Minus 4x1 plus 2x2 equalizes to 0. 2x1 minus x2 equalizes to 0. Ultimately, if you see, both the equations are giving the same solution, that x1, okay, let me do, it's nothing. If you cut this, you will get the same thing. Yeah, right, this equation equalizes this equation, obviously. So 2x1 is equal to x2, so you can write x1 is equal to x2 by 2. Okay, easy. So we can take this, this equals to this, and in case of, suppose we have ratio proportion, that x, okay, let me clear it. I'm telling you, x1 divided by 1 is equal to x2 divided by 2 is equal to k. We have done this in ratio proportion in class 10, I think. Okay, so we can take this. Let me remove this. Okay, so x1, sorry, x1 is equal to k, and x2 is equal to 2k. So this is the value of eigenvector corresponding to the eigenvalue minus 1 in this case, in the given problem actually. So x is equal to x1, x2, right? So x1 is k and x2 is 2k. Just write that k, 2k. Bring that k out if you want, or you can keep this way. So this is the value of eigenvector for lambda equals to minus 1. Okay, so we get a corresponding eigenvector for a given eigenvalue. So now our objective is to find the eigenvector corresponding to the given eigenvalue minus 6. So our case is now minus 6. Okay, can you, if you have understood what I am telling from the last 13 minutes, 13 to 14 minutes, can you find this in your own? You can pause the video and try this. Okay, okay, please try it, and you can comment it down. That will be a fun. So okay, I hope you have tried by pausing the video. So let's do it. It's e minus lambda I is equal to x, sorry, 0. So a is minus 5, 2, 2, minus 2, right? Minus lambda, same thing. Here it is minus 6. Yes, minus 6, 1, 1, 0, 1, sorry, 0, like this, which equalizes 0. Next, minus minus is plus, so yeah. So what we have is minus 5 plus 6. Let's do it in the next page. Minus 5 plus 6 from here, and minus 2 plus 6 from here. Minus 2 plus 6. and 2 plus 0 is 2, 2 which equals to 0. Here it's x, which is x1 and x2. You should write थोड़ा बड़ा लिख दिया यहाँ पर, मुझे नेक्स्ट पेज में जाना पड़ेगा. So it's 1 2 2 and 4 4. Am I right? Yeah. Here it is x, actually x1 and x2. And please write in matrix form the zeros and zeros. That is better. But nobody is going to check your steps in competitive exam. I am solely teaching for your competitive one, not your undergraduation one. For in your undergraduation paper you have to write this, or the examiner might cut your marks here if you don't write in the matrix form. Yeah, for competitive exam you can just write here x or 0 for time saving. Time saving is very important. Okay, leave it. So here we are getting the equation 1 1x1 and plus 2x2, right? Yeah, x1 plus 2x2 is equal to 0. Again we are getting same thing, 2x1 plus 4x2. So these are the ultimately same things, so we can write x1 plus x2 is equal to 0. So x1 is equal to minus 2x, or we can write x2 is equal to minus x1 divided by 2, same ratio proportion thing. So we can get x1 is equal to minus 2k and x2 is equal to k. Okay, so x1 x2 is equal to minus 2k and x2 is equal to k. Okay, so this is the answer. Okay, so you might have a little bit confusion that in books you can find here minus, sometimes here minus. It really doesn't matter. Okay, this is ratio proportion, you can take this minus anywhere else. Okay, but in the examination you will never get finding eigenvectors problem. You will only get eigenvalue problems. If eigenvector problems might come, they will never confuse you in options, or they can give MSQ that this might be the answer or that might be the answer. So both are correct, so you need to mark both. Okay, so this is x2. Here it is capital X2, you can write. For lambda is equal to minus 6, it is lambda 2. Okay, this is just a writing fashion and nothing else. Okay, yeah, and this is x1, you may write for lambda 1 is equal to minus 1. This is just index I am using, they are not so important. These are what is the definition is that, 1 minute, yeah, the definition is that this x2 is actually the eigenvector corresponding to minus 6 eigenvalue, and x1 what I have written is the eigenvector corresponding to minus 1 eigenvalue. So this is how you need to find eigenvalues and eigenvectors in 2D case. In the next video I am going to show you how you can find in 3D case. Okay, thanks for watching the video. Hope you enjoyed the class. Thank you.